and cosine functions. So, if the values of a function are the same for each given interval of the domain, the function is said to be periodic. The interval is the period of the function. So, here, right, every certain amount, we get a peak of this function. Every certain distance, we get a trough of this function. So this function repeats the same values every certain distance. That's a period. So this is periodic. What is the period? The period is how long before it repeats, right? Goes up and then down, that's one period. So the period for this one equals 4. One up and down cycle is 4 units on the x-axis. Here, the y values keep increasing. They don't repeat in a predictable pattern, right? We don't get the same y values infinitely. So this is not periodic. So let's graph sine function. Use your unit circle. So on your unit circle, right? So here our x-axis is in radians. So on our unit circle at 0 radians, right? That is on the positive x-axis, and our point is 1, 0. And remember that the sine is the y-coordinate of that point. So sine of 0 is 0. At 90 degrees, or pi over 2 radians, the function is, the coordinates are 0, 1. So at pi over 2, our y value is 1. And then at pi radians, this is negative 1, 0. We're back down to 0 at pi. And then at 3 pi over 2, that's 0, negative 1. So at 3 pi over 2, we're down to negative 1. And then when we come back around to 2 pi, we're back up to 0 again. So that gets us the beginning of the sine function. But we can do a little bit better, right? At pi over 4, our coordinates are both root 2 over 2. And if you do root 2 over 2 on your calculator to get a decimal approximation, it's about 0.7. So halfway, so root 2 over 2 should be at 0.7, this is 0.5, 0.7 should be here. And then at 3 pi over 4, you're going to have that same root 2 over 2, which is also going to be 0.7. Should be like that. And at 5 pi over 4, you're going to have root 2 over 2, but it's negative. So that's going to be here, and that's also going to be the same at, it's going to be here. And that's also going to be the same on the other side. So that starts to give us the sine function. We also know that at pi over 6, our function is equal to 1/2. And the same thing, sine of 5 pi over 6 is 1/2. And sine of 7 pi over 6 and 11 pi over 6 are negative 1/2. So once we've plotted all these points, we start to see what the sine curve looks like. And if we connect all of these points together, that gives us a sine curve. And because these points are based on a circle, this function is periodic. So if I went counterclockwise around the circle, I would start at negative pi over 6. I would be at negative 1/2. And then at negative pi over 4, I would be up to I would be down to negative 0.7. And at negative pi over 2, I would be at negative 1. And so then I go back down, and at negative 5 pi over 6, I'm at negative 0.5. At pi, I'm back at 0. And I know that I'm going to be at 1 at negative 3 pi over 2, and 0.7, and 0.7, and 0.5, and 0.5. And so this then gives me the other side of the curve, which you can see is a periodic function. And the period is the amount of times it takes to go one up and one down, and so that period is 2 pi. So properties, y equals sine x. The period is 2 pi. The domain is the set of all real numbers. The range is the set of real numbers between negative 1 and 1 inclusive. All right, all of our y values can only be between negative 1 and 1. The x-intercepts are located at multiples of pi, where n is an integer. All right, so whole number multiples of pi. All right, so our shorthand for n is an integer looks like this. The y-intercept is 0. It's where it crosses the y-axis. The maximum values are y equals 1 and occur at 2 pi multiples of 2 pi multiples of 2 pi plus pi over 2. Minimum values are negative 1 and occur at multiples of 2 pi plus 3 pi over 2. Find sine equals 9 pi, a sine of 9 pi over 2 by referring to the graph of the sine function. So, it would help if I had a graph of the sine function. But we know our sine function goes through 0 at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. 5 pi being 10 pi over 2, 4 pi being 8 pi over 2. So I'm looking for halfway between 4 pi and 5 pi. So from 0 to pi is the up loop, pi to pi over 2 is the down loop. And we've got an up loop and we've got a down loop, and so at 9 pi over 2, that's going to be right in the middle of our up loop. And so sine of 9 pi over 2 is equal to 1. Find the values of theta for which sine of theta equals 0 is true. So going back to, we've got the up and the down and the up and the down and the up and the down, right? Where does this function equal 0? It's all of the multiples of pi. So pi, 2 pi, 3 pi, 4 pi, 5 pi, right? So theta equals pi n, where n is any integer multiples of pi. So that also includes the negatives. So negative pi, negative 2 pi, etc. Graph y equals sine x for 3 pi to 5 pi. So it's not a great straight line. Someday I will learn to draw a straight line, but today is not that day. All right? So 3 pi, 4 pi, 5 pi, we know at all of these, the function is going to be equal to 0. 4 pi is a multiple of 2 pi. So that's the bottom loop. And so from 4 pi to 5 pi is the top loop. And so this point would be at 1, and this point would be at -1. And it looks something like this. It's not a great graph, but I'm a math teacher, not an artist. Your cosine function, right? So again, using your unit circle, your cosine at 0 radians, this point is 1, 0. So your cosine is 1. At pi over 2 radians, you're at 0, 1. Your cosine is 0. At pi radians, you've got -1, 0, you're at -1. And at 3 pi over 2, you're at 0, 1, you're at, you're back at 0. 0, -1. And then at 2 pi, you're at 0 again. So your function, at 2 pi, you're back at 1. At 2 pi, you've completed 1 period, and you're back at 1. Your cosine is equal to 1/2 at, that's pi over 3. So at pi over 3, you're at 1/2. At 2 pi over 3, you're going to be at -1/2. So 2 pi over 3, you're at -1/2. And you're going to be at -1/2 at 4 pi over 3, and +1/2 at 5 pi over 3. You're also going to get the square root 2 over 2. Your cosine equals square root 2 over 2 at the pi over 4s, which is going to be here at pi over 4, you're at root 2 over 2, which is about 0.7. At 3 pi over 4, you're going to be negative root 2 over 2. And at 5 pi over 4, and then you're going to be back to positive root 2 over 2 at 7 pi over 4. So you get a sine curve that looks, or a cosine curve rather, that looks like this. And the cosine graph is symmetric with respect to the x-axis because of that x-intercept being at, or because of that y-intercept being at 1 in the middle of a peak. And so the other side of your function looks like this. And so then you go back up through 0, and here you're at 0.5, and here you're at 0.7, and here you're back up at 1. And so this is the other side of your cosine function. So literally, take the values of cosine from the unit circle and plot them, and it looks like this. Y equals cosine x has a period of 2 pi, just like with sine. The domain is the set of all real numbers. The range is from -1 to 1, inclusive, just like with sine. The x-intercepts are located at multiples of pi plus pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, etc. Y-intercept is 1. Maximum values are y equals 1 and occur at the multiples of pi. even multiples of pi. Minimum values are y equals -1 and occur at the odd multiples of pi. And that's it for cosine functions. Stay tuned next time for amplitude and period, which are transformations of sine and cosine functions. And now I have to go feed my cat. She's starving. She's never been fed ever in a million years. Never been fed a day in her life.